Hello everyone, in this video I'll be talking about some more examples of set theory. That means some more examples on operations of set. To understand the basics and fundamentals of operations of set, you can see the series, the entire playlist right from the beginning. So if you see here, the question says find the union of following pair of sets. So I've got two sets x and y, and set x has certain elements like 1 3 5, and set y has certain elements called 1 2 3. You can see them listed right here, and my objective is to find out the union of these two sets. That means my objective is to find x union y. That is what I am intended to do. So let us go ahead, and the solution of this particular problem is very simple. So if I go with Van Euler diagram, then that's how the Van Euler diagram can be utilized. I have a set x here and I have a set y here, and this is the universal set. So if I see 1 and 3 are going to be here, and if this is x, the 5 is going to be here, and in y I can simply see that 2 is going to be here. So fundamentally x union y in this case, and I'm going to tell you a little technique how to do it. Start writing with the elements of first set x. So what I have in x, 1 3 and 5. So I've completed the elements of first set. Now I'll start seeing the elements of second set. The first element is 1. Now if you see, 1 is already available here. There's no need to write it. Then I see 2. Is 2 available? No, it's not. So I write 2. And then I see 3. 3 is already there, covered. So there is no need to write it. So that's exactly x union y. And if I see mathematically, x union y actually contains an element x such that x belongs to x or x belongs to y. So fundamentally I have to see that the element is supposed to be either in x or in y, and it should not be repeated. So 1 3 5 2, that's the solution of the problem. Let us see another problem one more time. I have something like a is equal to a e I o u and b is equal to a b c. So you can see here b is equal to a b c. Let me just kind of write it again with a different color. So you have got a, which is a e I o u, and you have got a set b, which is a b c, and I want to find the union of it. So how would I do a union b? Once again, I'll use the same technique. First I'll write all the elements of a, which is a e I o u. Then I'll see what are the elements in b. There is an element called a in b, which is already covered. You can see it right here. There is an element b in b, which is not covered, so I'll write it. And there is an element c, which is also not covered, so I'm again going to write this particular element right here. So the union contains a e I o u b and c. So that is a union b. And simply, if you want to drop the Venn Euler diagram of the same thing, you can do that. Let me go ahead and see another examples. The first example says a is equal to x such that x is a natural number and multiple of 3. So what I'm going to do is, this is I would say set builder form. So what I will do is, I will try to first of all write the elements or the members of this particular set, and once I write the members of this particular set, then further it will be easy for me to find out the union of this particular set. So what would be a? A is a natural number, so definitely it is going to start from 1. What are the natural numbers? It is 1 2 3 and so on, you understand that. But it is a multiple of 3. So 1 is the first natural number, which again is not going to come into this particular set. I'm extremely sorry. Why it will not come? Because I have to write only multiple of 3. So multiples of 3 will start from 3, then second is 6, third is 9, then that is 12. How do you identify these particular things? That means the numbers which are divisible by 3 right from the beginning. So if you see, or you can think about the table, how do you actually memorize the table of 3? 3 3 is 6, 3 3 is 9, 3 4 is 12, and so on. So it is going to continue. You keep on multiplying. If you want to calculate the multiples of 3, you multiply it 1, multiply it with 2, multiply it with 3, So how do you count the multiples? That is biggest confusion for the student sometimes. So it is actually the first multiple is 3 into 1, the second multiple is 3 into 2, then it is 3 into 3. So what you do is you keep on multiplying 3 with the natural numbers 1, 2, 3, and so on. Now let me see how exactly I write a tabular form of b, which is says natural number less than 6. What are the natural numbers less than 6? It is going to be 1, 2, 3, 4, and 5. So there is no 6, it is less than 6, and now I want to find out a union b. So in such cases where a is indefinitely large, so in that particular case, how do you actually write the elements of this particular set? So I will start with the one which has I would say countable number of elements in it. So I will write with b 1, 2, 3, 4, 5 are the elements of b, and then I'll start with a. So a, the first element is 3, already covered. The second is 6, is not there, and then after that 9, 12, and it continues. So that's how the union of these two sets can be covered easily. Now if I look into next particular example, the first set a x such that x is a natural number between 1 and 6. So first of all, I'll again write a tabular form of a. It will be easier for me. So natural number, uh, I would say x is greater than 1 and less than equal to 6. So it is actually simply going to be 2, 3, 4, 5, and 6. So you have to carefully watch the signs what are here. It is less than x is greater than 1, less than and equal to 6, so equal to 6. And then I'm going to write b. B is a natural number between 6 and 10. Now if you see both the sides, neither 6 or not 10 is included, so it is definitely 7, 8, and 9. Now and write a union b once again. Now since both the sets I can pretty much count the numbers or elements in it, so I'll definitely go with my first particular method. I'll write first of all a, 2, 3, 4, 5, 6, and then I'll see what is there in b. So if I can see neither 7 nor 8 and nor 9 is actually covered in this entire setup, so that is going to be a union b. Let's see a few more examples here. Got a couple of more examples. If I see the set a, which is 1, 2, 3, and b is a 5, which is also called as a null set. So this is the example which I want to cover. And if you see the next example, then it is actually a is equal to ab, b is equal to abc. If a is contained in b, then what is going to be a union b? So first of all, let's see the first example where I have got a as 1, 2, 3, and b as equal to 5. So in this particular example, I hope the condition is very, very simple. You have a union b here, and that is going to be 1, 2, 3, and if you see there is no element in b, so I don't think any member is to be included. So this also give rise to one particular thing, that a union of phi is equal to a. That means if you union it with f5, because phi is null, that means there is nothing in it. If there is nothing in it, what to be included? So the structure of b is something like this: no element in it. Let's see if a is equal b is equal to ab, b is equal to abc. So let us understand this entire structure by using Venn Euler diagram first of all. So b is a bigger set here, having 3 elements a, b, c. So there is a, there is b, and there is c. This is exactly what b is about. And if you see a, let me pick up a little different color here to mark it clearly. So this particular thing right here is actually a. So a is contained in b, and that's the universal set, right? And I just have to see that what is going to be a union b. So if I look into a union b, and if I use the same principle which I was doing, first I will write the elements of a, which is a and b. Then I'll start writing the elements of b, which is simply a is already covered, b is already covered, only c is left. So C comes from B and A and B comes from A. And if you see this entire structure, this is equal to B. So I can simply write one more argument here, that if A is contained in B, this simply implies A union B is equal to B. So that is about A union B for this. Okay, this is a big example. I'll try to cover maximum of them as much as I can. You've been given by 3 sets A, B, and C, and I'm going to count first of all A union B. So I'll do few of them. Some of them you can do by yourself. I'll try to count A union B. Go with the same principle. First of all, I'll write the elements of A, 1, 2, 3, 4. Then I see the B, it is 3, 4, 5, 6. So 3 and 4 are already covered. I'm left with 5 and 6. Let's see second one, which is saying you A union C. So I'll again write A first of all, 1, 2, 3, 4. And in C, if you see 5, 6, 7, 8, none of them is covered. So I'm going to go for 5, 6, 7, and 8. Okay, let me cover it with curly brackets. Let me go with different color for a better understanding. The third one says B union C. So what is going to be B union C? So first I'll write the elements of B, which are 3, 4, 5, and 6. And then I'm going to write of C. 5 and 6 are already covered, so I'm left with 7 and 8. So that's how you can do fourth, and by yourself I'll do the fifth one, which says A union B union C. So I'll simply go with the same principle. First I'll write A, which is 1, 2, 3, 4, 5, 3 and 4. Then I'll see B, 3 and 4 are already covered. The left elements are 5 and 6. Then I'll see C, 5 and 6 are already covered. The left out elements are 7 and 8. Let me do one more, and let me do the last one, which says B union C union D. So let me write it out. First of all, I'll count the elements of B, which are 3, 4, 5, 6. And then I'll see the C element. 5 and 6 are already covered. I'm left with 7 and 8. Then I'll see the D's elements. 7 and 8 are already covered. I'm left with 9 and 10. So some examples of unions of sets. Thank you very much. Let's see in the next video.